Okay. Is this visible? Amit?
Yes, it's visible. It's
Okay, so
visible.
let's. Okay, so should I start now?
Yes, please. Yeah.
Okay,
Thank you.
perfect. So yes, so today we are going to discuss Python, which is most likely first part of our discussion. So let's start. So I am Sudhir. I am currently a data scientist for past 6 months. Before that, I was in academics doing a PhD in physics and then postdocs in NTU. So, okay, yes. So the first thing when we plan to design a programming language, the first thing we have to decide is for whom we are designing it. Whether we are, as you can see on the screen, whether we are designing it for machine or we are designing it for a human. So what does that mean? So that means that uh, in the first this thing, if we are designing it for machine, we will make it in a language which is more easy for a machine to understand. And machine understands 0, 1, all those kind of like binary things, which is very hard for us to understand. We understand numbers and we understand different languages. So like we talk in English or Hindi or Bengali. So if the programming language has to be developed which is close to us, that will be called human friendly. So broadly this way, C, C++, Fortran are more like machine friendly languages, which is easier for machine to understand, and Python, MATLAB, and few of others like Perl, they are that they are much easier for us to understand because sometimes they appear to us like English syntaxes. So uh, earlier we used to hello. Okay, so earlier machines were not powerful, so most likely we used to develop languages which are easier for machines. But right now machines are very powerful, so we make it we choose the language which are easier for us because machines are very powerful, so they can anyway understand, and that makes, and we choose to make our life easy. So, and in this context, let's discuss Python. Okay, so why choose Python as a programming language? The first reason is easy to learn. If you get started, initially it feels like English language. So if you have done programming in C, C++ or any other languages, using Python is much easier. That's the first and the most important reason to use Python. Second is open source. You don't have to pay any money into that, and you can use or you can contribute. You can make libraries and contribute to Python. You can use it for free. And the third reason would be that it has many packages. So these packages are because Python is open source, so anyone can make a library, a package, and make add it to the Python languages. So just because it is open source, it has got so many of these packages, and which is one of the main strength of Python. And the fourth would be that it's highly readable. As I said, it sometimes feels like English language syntax, and this highly readable should be appreciated more because we write a program once, but we read it many times, and by us even. And suppose we transfer the code to others, it has to be read by others. So this readability is very important. So that makes code for easy for anyone to understand and reproduce the results we want. So this would be, I would say that their main important strength of Python. So, okay, so let's discuss the contents of the day. So this first part, so we are going to cover very basic structure of Python. Python is very diverse, very powerful, but at the same time easy to get started. But we hope that everyone is at beginner level, so we'll keep it simple. So first we covered these five things, which is using Python as calculator, then list, which is the data structure, then how to do iterative computation with loop, and then logical condition functions. These are the core of Python programming language. We will cover this thing, and after that we will discuss two of the important packages that one has to use a lot, and it we may cover in some other session. So which is more of going into data science. So as for now, we are focused on Python and not going to data science. So we will be covering these 5+2 topics today. Okay, so let's discuss how to use Python as a calculator. That's the simplest way to get started. Suppose I go to Python on any terminal, or which I will show later, and write x is equal to 1. So that x will be my variable, x is variable, and 1 is the value here. So when I write this variable x is assigned a value of 1. Okay, so like you can see here on the leftmost example, suppose I want to do some simple addition. I will just write x is equal to 2. That means this variable x is assigned the value 2, y is assigned the value 3, and then I do the addition, z equal to x plus y. So what happens here is that it takes the x and y's value defined above it, calculates it, and the value which is added is assigned to a new variable z. Similarly, we can go and we can do subtraction. So I said that A is assigned a value 4, B is assigned a value 2, and C is B minus A. So B is taken as 2 here, A is taken as 4. The value is calculated here, and the result, which will be minus 2, that is assigned to C. And we can go to we can take a more complicated name of these variables. I can, instead of x or a, I can say it's value 1, value 2, and as you can see, I can multiply these values and assign to a new variable, which is final value. Okay, so I think the theory is easy to understand, but let's implement it in so that we can see how it's working. This is very simple, but just to get started with here. Okay, let me do one thing. So how to assign a value in Python. This is Jupyter Notebook. This is one of the most popular kind of place to do this thing, Python programming, or for your analysis part. I directly jumped here, but later if someone has difficulty, I can help in that, how to get started using Jupyter, which is a package of uh, Anaconda 3, which is basically an environment for doing Python. It has all these libraries of Python. But maybe after the talk, I can help you that if you want to get started with this. So as for now, we will focus on learning Python. Okay. So I say variable x, and then I assign the value 1. To run this, I just do shift enter. Okay. Now I have a variable x, which is a value 1. Let's see this one. To see this thing, I can print it. Print x. This is the syntax to print the value of x. And we can see it has printed 1. So it is as expected. Now let's do a simple addition. This is exactly we are going to follow what I showed on the slide. So I say x is equal to 2, y is equal to 3. So these are the two variables I have defined, and I say z is equal to x plus y. Okay. And to execute this whole cell, this is called a cell in Jupyter. And to execute this means to run this cell, I just do shift enter, and this calculation is completed, which we can see by printing the value of z. Okay. 5. This is all on the expected line. Let's repeat it again just to get more familiar with this. Equal to 4, y is equal to 2, and z is equal to y minus x. I can print here also. Minus 2. Okay, let's do one more thing and then we move to the next topic. Okay, so we did addition, we did subtraction. Let's do one of multiplication. X equal to 3, y is equal to 5, and then z is equal to x into y. Okay, here I execute it, and I expect the value of z to be 15. Good. So these are very basic mathematics: addition, subtraction, multiplication. We can do it and kind of do more complicated stuff also. So let's do one complicated thing. A is equal to 2, B is equal to 4, C is equal to 3, and D is equal to 5. Okay, unless you add something more complicated, something value, which is a into B plus B into D by C plus C star star A. So this is, I multiply A by B, and then I multiply B by D, and then divide by C, and then this is C to the power A. So this is slightly more complicated than this one, and we get this. So this is, it's kind of example of using Python as a calculator. So one more thing I wanted to add, that suppose x is equal to 2, and then I write x is equal to x plus 3. What should the value of x? So x is equal to 2 is fine. The variable x is assigned the value of 2. But what is this x is equal to x plus 3? This looks like mathematically this wrong, but this is not mathematics. This is how the programming language is defined. So this is basically what is doing is that first first the quantity or the statement on the right hand side of the this equal to is computed. So in this statement, x is equal to x plus 3, first x plus 3 is evaluated. So it takes the value of x equal to 2, then add 3 5, then it assigns the value 5 to x, which I can show right here. 5. So the main point to understand is that whatever is on the right hand side of the this equality, that is evaluated, and whatever is the value is assigned to the variable on the left side. Okay, so now let's get back to the slide. So, okay, so this is very simple introduction to using Python as a calculator. Okay, now let's move to list. So list, there are the one of the really big strength of Python is that it has a very enhanced or very like kind of diverse and strong set of data structures. And I'm going to discuss only one, list, which is the most popular one. And in most of the analysis, that will be sufficient to know list only. So as you see in the previous slide, I wrote x is equal to 1. That means x is a variable that is assigned a value of 1. So that means variable x is holding only one value, that is 1. Okay, but suppose I want to hold so many values, more than one values in only one variable. So as for example, suppose you have taken the measurement of weights of people and you want to keep all of them in one variable, because that will make my analysis easier, as we say, see just when we go to the notebook. So what I do is to keep so many values in one variable. So these are the values from 54 to 64, and weights is the variable. So what I do is I put a bracket, this is square bracket, and put all these values separated by commas. These are the only two requirements. Once you put the bracket and then square bracket, and then you separate the values by comma. If you write this thing, now weights is something which is called list. So this is called a list in Python, and this has some basically rank. This is rank 0, rank 1, 2, it start like this one. So we can, it's rank called rank or index. So we can somehow get these values using their position also. So index is kind of representative of their position. So 0th position, first position, and the 5th one. So, so once we keep these values in this list structure, we can do a lot of things. And let's see how many, I mean, what kind of things we can do with it. Okay. Okay, so first let me define a variable, weights, which is equal to 54, 73, 48, 96, 45, 64. Okay. I just write these values and I shift enter. So weights is a list which I can see by printing that type of list. Type means shows that what kind of uh, data structure it is. You can say it says list. So this is now, you can always see the data type or the data structure type using this type statement or type command. Okay, so suppose I want to take only this, I don't want to use the full list. I want to take a set of a few numbers out of this list. So what I will do, I can do is I want new weights, that will be weights, and I say 0 to 4. Okay. So the what this will do is that it goes to the weights, this variable, this list, and it takes the values which are from 0 to 4 by index. So as I said, this is index 0. So this goes from 0, 1, 2, 3, 4, 5. But this doesn't, this is the starting index 0 and 4 will be the ending index. So this will go from 0 to 3. Whatever you write there, it goes to one element before that. So if I write 0, 5, this will go to 0 to 4. But if I am writing here 0 to 4, this goes from 0 to 3. So 0, 1, 2, 3. So this will pick up these values from the list, and this will assign in this new variable, which is new weights. Okay, let's do that here. Okay, see. So it has started from 0 here, and since it is 4, it has gone to 3. So 0, 1, 2, 3 here. So this way, sometimes these lists are very big, and we don't want to do the analysis with all of them. I can just select a new subset from this list into a new list. So this will be again a new list. So this is how to select a few elements from the original list. Okay, so now suppose that we make this measurement and we have this all this weight in our list, but we make one more measurement of the weight, and I want to add that value in this list. So the idea is that one thing I can go and just write the comma and declare it here, but sometimes that is not convenient because I don't want to disturb with the original list. So I can do is weights append 101. So it takes this list and adds this new value. So weights, this is the name of the list which is above, and this append a new value which is 101 to the list, which we can see like here. Okay, you can see that a new value is added. So this way I can add another element in my list. Okay, we can do one more thing. Suppose I want to arrange all these weights in an order, because this is not in ascending or descending order. We can simply uh, sort it. Let me put it here. Okay, so we can see this is, if I just take the list and call this dot sort, which is basically a function. So it takes the list and calls this sorting function on the list, and we can see that these numbers are all now arranged in ascending order, 45 to 48, 54, like this one. But suppose I don't want them to be arranged in ascending order. I want them to be uh, arranged in descending order. So I just take weights, I put sorting again, but in the bracket, I write reverse is equal to true. So what this does is, okay, now you can see if I do this thing, I can reverse, I can get the list in this descending order. So these are the few operations that you can do on list. There are many of them, and this is like this is very powerful, and there are so many of like more than hundreds of these functions to play around with that. So that makes our life a bit easier to do analysis. Let's say one more thing. Suppose we have, instead of measuring the weight of all the people in one list, we have done separately. So I have taken the weights of the female in one list. Suppose this yes, weights is measured by one person and kept in one list, which is weights of female. Yeah. Oh, sorry, 34 is not sorry, possible, but unrealistic. But anyway, weights of, and then here. Okay, so I'm saying that suppose we have measured this weights separately by two people. One is measuring the weights of female and other is measuring the weights of male, and these are kept in two lists. So weights of female and weights of male. And suppose for our analysis, I want to combine this list into one, because now I'm not going to regard kind of take care of this male or female. So I want to add these values in one list. So that can be simply done by like this. Let me start it. I take weights of female, which is first list, and then I just put addition, and then I put weights of male. Okay, and whatever is this, I give the name combined weights. If I just print the value, I can see these values are appended. These two lists are added. First is the female values 34, 44, 54, and then are the male values 45, 55, 65. So this is that we have two separate lists just by simply addition, as we do with addition of two numbers. I can add two lists also. Okay, let me put one more thing. Okay, so suppose I have this. Take this list only. Declare again. Just take the value. I can just define the values again here, so that I don't care about the changes I made, because when I did sorting and other things that made changes in the values. So just to not to care about them, I just write it again here. So now this is the list weights with these values. Suppose I want to add the value of all the elements in the list. So I can put the variable name sum of weights, which I can simply do is I put sum of weights. Okay. This simple thing, I just take the weights name and put the sum over it. So this will give me the sum of all the values. And I can do one more thing. I just put length of weights. I put length, and then I give the list name, and this will tell me how many elements are there in the list. Okay, so now you can see it says 6. 1, 2, 3, 4, 5, 6. So you can see I can add all the numbers in the list, and I can see kind of get the count of the number of elements in the list. So like we saw a few functions or the few things we can do with list, but there are a lot more, and basically all of these things make analysis easy, like adding, deleting, or adding or sorting anything. So I think we have a little idea about lists now. So we can move to the next thing, which is something called iterative computation, which is basically done by loops. So suppose that I have measured the weights in kilograms, which is kept here. Okay, but I want to I want to convert these values into pounds now. So how to do that? So the idea will be, because this is iterative computation, because I am taking 44, I want to convert that to pound, and then 73, and then I want to convert this thing to pound, and then 64, all the values. So the same thing I have to do for all the values. So this is kind of repetitive because for the same element, we have to repeat the computation. So this is the Python code for simply doing this thing. So what it does is first I define a list. So when I write weights, LBS, and I just simply put this bracket with no values, that means empty list. It doesn't have anything, zeroth element, this empty list. Then this is basically a loop, which is the most common loop in Python, which is called a for loop. So I write this syntax for weight in weights kilograms. Okay. So what does that? For means this statement, what it does that it goes through all the values in this weight kilograms. You can say this weights underscore kilograms is the list name which we want to convert into pounds. So when we go through it, weight is a variable name. So in first iteration, this weight will take the value 54 and then it will multiply 2.2, which is the number I need to convert to pounds. And so this will be the new weight corresponding to 54. And then this new value, which is in pound for 54, is added into this empty list. Okay. So it's initially this weights underscore LBS, it is empty list. When for loop goes, it picks the value 54, converts into pound, and then add into empty list. After that, weight, this variable weight takes the value 73. It takes 73 and then again make the conversion, and then new weight is the pound equivalent for 73, and it adds into this pound list. So it keeps going through till it reaches the last value. So in the last iteration, weight takes the value 64, multiply by 2.0, and then gets the weight equivalent in pound and add into the weight underscore LBS list. So let's simply see how to implement this in Python. Okay. So let's me do in three. First, I define all the weights in kilograms, which is 54, 73, 48, 96, 45. And please feel free to interrupt at any moment you like, or if I'm going too fast. Amit, you can also tell like if you want me to go slow or there's anything you want to be changed.
No, I think this is fine. I mean, the pace wise, it's okay, but I think still, I mean, it's quite like C or C++, I think, till now.
Exactly. Yes, exactly.
So I think you can go ahead. Like the more we see, we'll have some idea, right? I think somebody has a question. Anybody has a question, you can ask now because it's supposed to be a hands-on. Sneha, there was a question from Sneha Basu. Suhen Basu. Anyways, like if you have any question, you can just ask during this one.
Otherwise, in the end, I will share all these notebooks with all the code. You can play with it, and then because once you have some slight introduction, it's easier to play with it. And this programming language is always learned by doing it rather than listening. I mean, you have to spend some time getting familiar. That's how we learn it. So okay, anyway, in the end, I will share the notebook, and that should be, I think, better now then.
Right, Sudhir, that'd be better actually.
Okay, sure. So okay, so let's get back to the implementation of loop. So this is my weights in kilograms, the 6 values which I want to convert into pound. So the first I define all the weights in kilograms, and these values are kept in a list. Here I defined it. Okay. Then I say for. For is a Python keyword that means go through all the values. That for means go through all the values in the list. For, and then I define weight. Weight is a variable. I can give any name I want here. That is not restricted because it's not used anywhere. So this is just a variable. I can choose X, Y, Z. I can choose my name also. No problem with that. And then say in. In means in the list. and then I have to provide the name of the list, which is weights kilogram. So what this line does is that it goes through each value in the list, which is weights underscore kilograms. Okay. So as I told in the first iteration, weight will take the value 54. Here value and then multiply this thing by 2.20. It takes the value 54 multiplied by 2.20 and it calculates whatever value it calculates, it assigns in the new this variable which is new weight. Okay, and then simply here I have to define my empty list also in which I want to put my value. So now here new weight is the converted value. Sorry, I have to define an empty list. So this is an empty list. So I have calculated this new weight. I can just put this new weight in the list using append method that we already saw when we were discussing list. So I take the list which is initially empty and append the value new weight. New weight. So what is that? This line goes through these 3 lines of code, goes through each element in the list, convert it into pound, and then put in the new list, which new list is weight underscore LBS. Okay, and I can just print this value in LBS. So if you just write this thing in Jupyter, it kind of prints. I can also use print here to print this thing. This works, perfectly works, but this is more of a traditional method, but Jupyter is kind of a modern platform. So it works without print also. So I don't have to type an extra print. It works. I can see all these values are converted into pounds now. So let's repeat this calculation and get back to from pounds to get back into kilograms again. So let's do weights. I follow the same thing. I define a new list which is weights, kilograms, and new, because I don't want to interfere with the original list. Okay, I define an empty list. Okay, now I say for weight in. Now I pick the weights from LBS. So now this weight will take each value from this list and then I say my new weight is equal to weight. Now I have to divide it 2.20 because then I have to go back to that simple transformation. And once I get this value exactly similar to before, and this new value I append it to my list which is weights, kilograms, new underscore weight. Let me just print the value of weights, kilograms, new. We can see if we have returned to the same value 54, 73, 48, 96, 45, 64, except this 0. This is basically just a simple thing. Earlier here it assumes that these are integer because we have not put any decimal numbers in this calculation. Everything is decimal, so we thought that it is a more of a real number rather than integer. Okay, so we saw these 2 examples of using for loop. There's other loops also, while loop, but which are not so common. This is the most common loop, which will be using a lot more time. So other things we can explore later. Okay, so let's move to the 4th topic, which is using condition. Okay, so anyway,
we have one question from
Sure.
audience. That's list and tuples are the same. Can't we override the existing list?
Existing list I can overwrite, but not tuple.
What's the difference? I mean, I understand they're both like sequential objects, right? Like it's
Yes.
almost the same as list, right? What's the difference?
So difference is, I think something like tuple is supposed to be more strict. Sometimes you don't want, like suppose you write a code, but you don't want anyone to disturb the original thing. Okay. So you will use tuple because you don't want anyone to disturb the original thing. No one can disturb that. So use tuple. And in list, okay, let them change it. I think that's the reason. Uh, Tuple is very rarely used. Most of the time you use list. So, and since tuple is not allowed to change it, so it has some other, what to say, other way, like more strict way of keeping it. So it's more memory efficient and more computationally efficient to use tuples. But again, it's less flexible then. Is it
Yeah,
okay?
that should be sufficient, I think. Yeah, that's pretty clear.
Yes. So, but mostly we use list, very rarely tuples. But I think that when you go to more of serious competitive programming or like more serious software engineering, then I think you use tuples more. Or like, I really can't go on like really comment very not theoretically and all.
No, I think this is understandable. Like, so I think you can go on to the next one,
Okay,
next
sure.
topic. Yeah.
Okay, so now, okay, so in like real life, always we have this if, else, but. So that things also occurs in programming. So let's see how to deal with these cases. If this is true, if this is not true, whatever happens, all this what if, but all those cases, how to take care of them in Python. So okay, suppose weight is, I have given a weight which is 70, which is just a number here, not list. Okay, and I say that there's a weight limit of 100. Okay, if the weight is below 100, I say the person is not overweight. But the if the weight is greater than 100, I say overweight. So how to classify a weight into overweight or not overweight, how you implement this thing. So this is very simple. To the simplest thing is to write this thing on the left hand side. So this is if is Python statement, if, and then I write weight, which is the number, and then less than weight limit. Okay, so if the weight will be less than weight limit, this statement is true. When this statement is true, like the true and false of the binary, so this thing is always evaluated in binary. So here in this case 70 is less than 100, so this statement will be true. Then only we can the program will go to the next line and will print not overweight. But if the weight is here 110, this thing will be false and the code will not execute this. It won't go to the inside of the code, or whatever is inside the if block. We call it block. So you can see this print line is indented, some 4 spaces inside. So this is something called if block. So the statement inside the block will be evaluated only if the statement is true. Okay, so let's go to slightly one level up. You can see on the right. So we see we have added an else also. So here on the left we had only if, but on the right we have else also. Okay, so here if this statement is evaluated true, so say weight is 70, weight limit is 100, so this will be evaluated true. Then it will execute this statement and this will ignore the else part. But if this is false, suppose the weight is 110, then this will be false. It won't do the calculation for this if block, but it will do for the else block, and it will print not overweight. Okay, I hope it's clear. Otherwise, it will be more clear when we implement this thing, and then I can put the exact number and see it. Let me just clear it. Okay, so let me define. I want my weight is 70. Weight of a person is 70, and then I say weight limit is 100. Okay, now this Python, I like if it's a Python keyword, and then I put my weight is less than weight limit. Okay, then print not over weight. Okay, so till now we are talking about numbers only. But this is here, you can see this not overweight has turned red, and this has this two, inverted commas or see this thing. So this is basically a string, something called text. So here 70 and hundreds are number, but here this is text. So Python is also very powerful when dealing with text. Typically the traditional languages, which is basically say C, C++, Fortran, the three I have worked, they are very, very poor when dealing with strings. So what Python is much, much powerful and makes life really easy when you are dealing with this text, which is called strings. Okay, you can see I put 70. So this statement was evaluated as false. So this thing inside was not, sorry. So it was evaluated true. So it printed not overweight. But suppose I put 110, sorry, 0. So I put this thing, the weight is not less than weight limit. So this statement, conditional statement is false. It doesn't print anything. Now let me put the second thing, which is else condition we also wanted. So I can simply put here and extend this thing, else print. Okay, so as I was telling about, this is whatever you write inside if is basically there's only one line, but you can have many lines. This is called the statement under the if block, and this has to be, so if statement has to be ended with this double colon. That's a Python syntax we have to follow. Similarly, we have this thing under the else. It is something called the statements under the else block. So else has also to be ended with this double columns. Let's repeat this again. 100. So now we have only, till now we have only if, now we have put else. So it can put both categories, whether overweight or not overweight. 110 is overweight. I just repeat 70 is not overweight. So I think this is a very entry level introduction to if conditions. And then there are also more, it gets more and more complicated. You can also combine else with if, so something called if. So, and this if, then it can get looped and looped. So you can have multiple conditions. If this is true, then do this. If not, if this is true, then do this. And like we can have as many if conditions as we want. It's a total complete flexibility we have. So okay, let's do one more slightly more complicated thing. Okay, so let's do one thing. Let me first define the weights. Weights is equal to 54, 73, 48, 96, 45, 64. So actually we are going to combine all the syntaxes we learned till now into one simple code. Okay, so for this purpose I define my list, which is weights. Okay, now I want to split this list into two parts: people who have less weight and people who have more weight. Okay, so for this purpose I put a weight limit is equal to 70. Okay, 70. And then I want to split this list into two parts: people with the weights lower than 70 and people with weight higher than 70. So for this purpose, I will define two lists, two empty lists with CY and weight high into empty totally. Okay, now let's break into two lists. So for that purpose, we need to go through all elements of the list. So for that purpose, we have to use the for loop. So I say for, I define my variable weight, and I go through weights, which is the list defined above. Okay, let me define simple thing. Let's define x always. X is the variable which will take the value going from 54 to 64. And then I say here, I have the value of x. I say if weight is less than weight limit, Then I add this weight into the low, into the list, which is weight underscore low. Okay, I just add the value here. Okay, otherwise, which is else, I say weight underscore high, then add into the other list, because it is not, so if it is not less than 70, it certainly is equal to or higher than 70. So then in that case, I add the sorry, it's not weight now, it's always X now, because that is my variable name. Okay, I simply do this. Now we can see one thing. Okay, weight underscore low. Okay, see all the numbers. 54, it has omitted 73, selected 48, 45, and 64. The two values are omitted, which should be in high thing, high list, 73. So you can see that we are in this simple code. I have used for loop, I have used if condition. So these two things we learned, or the list also, like just list. So the main things we learned, we have implemented in a very simple code. Okay, so that's a nice little introduction to for loop. Sorry, if conditions. Okay. Okay, now let's move to functions. So one thing is that it will be really hard to appreciate function as for now, because that is more and more useful if we write many like lines of code. Say if you go for 100 lines or not more than 1,000 lines, so the code is hard to understand unless it is broken into very small parts. So to break into small parts, the small parts will be called functions. So that the idea is to break down the large code into small parts, and that we do by using functions. So as I written here, a large code should be broken into small independent units. This makes code much easier to understand, much easier to debug, to find errors, or if I transfer the code to anyone, he can understand, he or she can understand. So okay, so let's see how to define a function. So this is the 3 lines from def to return, how we define a function. So first I write def, this is a Python keyword. Python, once I read def, Python knows that I am going to define a function. Then I define a function, which is basically, then I have to provide a name for the function that I can call. Like people can call me by calling Sudhir. So if the function has to be called, it has to be some name so that I can call the function by name. So I have to provide a name here. So I define the name of the function, which is body mass index. And then there are some input to the functions. We have to provide some input to do calculation and give me some output. So here I have to provide, here I am providing 2 inputs. I can provide, sometimes you don't need to provide any input, sometimes so many inputs. So this can be empty here, and this can have like as many as inputs as you want. But here I have given only 2 inputs, which is weight and height. I provide this thing, and then I calculate BMI. The calculation happens inside the def here. It calculates, uses the weight and the height provided by me and does the calculation, and then return the BMI. So let's see here. So once I have defined my function, I can just call this function and provide these 2 numbers, which are basically the 2 numbers here, and just execute it. And then this variable, this number, which is BMI, will be given to this variable here. Okay, so I define my function, I call the function by calling the function with these 2 inputs, and I get my output, which is BMI, into the variable, which is my underscore BMI. So this is how you define a simple function. Let's implement it to see how it works. Okay, so let's define same thing. First I write def. Once I write def, Python knows that I'm going to define a function, and then I have to provide the name of the function, which will be body, which you can choose anything, but I choose it to be body mass index. Typically we choose the name so that it directly tells what the program is going. So otherwise you will forget later what the function is. So whenever we declare any variable or any function name, it should be as clear as possible so that one can understand by just looking at the name what it does. So I can guess that it is by the name that is going to calculate body mass index. Then after defining my name, I put the input variables, which is weight and height. Once I done that, I have to put this colon again, and that tells me that whatever I write below this line will be a part of this function. It's something called local or global. Once whatever I write inside, it will be a local quantity. I can't use it from outside that function. So it's kind of keeping things local so that you don't have to worry about a lot more things. So and then once I have this input weight and height, I can just calculate BMI is equal to weight divided by height square, so which is height into height. Okay, then I just say that once I call the function, I want to return the output to be BMI, which is this value. Once I shift enter, and now I have this function ready. Okay, so let me call this function, which is body mass index. I provide the name to call the function. Then I put the values. So I'm going to put 65. First weight has to be in kg, and then height has to be in meter. Okay, so this will directly call the function. Okay, let's see what it does. Okay, it has directly printed the value. But many cases I don't want to print the value. Whatever, so this has returned the value BMI for the weight and height of these two values, and directly printed it. But if I want to use that value and put in other variables, I can just take the return output in a variable, which is my underscore BMI. Okay, I have to print it. Okay, here. Now let's say that, okay, 70 kg. I can say it's increasing. Yes, so this is very simple example of function. Now let's write slightly complicated function. So that, and this is basically going to combine a lot more. Okay, yes, let's write this and then we see how it works. So okay, I'm going to define def. Okay, so what I'm going to do is that here in this function we calculated only BMI. So we know that we categorize BMI into 4 categories, which is obese, overweight, normal, underweight. So now I want to calculate BMI and then tell me my BMI and which category I am in. So I'm going to write a function for that. So def, I again use the name body mass index, and then I provide the weight and height. Okay, and this is same as earlier, and then I calculate my BMI, which is basically weight by height. I can use square like this. Okay, and then return BMI, but that's it later. Okay, first I don't want BMI. I want BMI and the category, which category I'm in. So the standard is that if BMI is greater than or equal to 30, I say the category is obese. Okay, here. Okay, so this takes category if the BMI is greater than 30. So if BMI is 30, this statement will be executed and we get the category value obese, and whatever I'm going to write below that, those statements will be disregarded because the first condition is true. Okay, but now write L if. Okay, so what this is the, okay, BMI is equal to, okay, let me write and then I explain it. Okay, so if BMI is not greater than equal to 30, then certainly it is less than 30. And if that happens, then you come to else, if, which is between else is a combination of else and if. So if this condition is not true, then it comes here and then ask else if BMI is greater than 25, then category is overweight. So if BMI is greater than 30, this first condition is true, and then it ignores these two lines. If it is less than 30, then only it comes to this third and fourth line, L if and category. And if this second condition is satisfied, which is BMI is greater than 25, then it says that category is overweight. We can again extend it and say if this both conditions are not true, and if this condition is true here, okay, and then we have to put this column here. Then I say my category is normal. Okay. Normal. Okay. Third category, if the value is greater than equal to 18.5 but less than 25, because if it is greater than 25, the second condition will be satisfied and it won't come to this third set of statement. Okay, and then if this all three conditions are not satisfied, then you put else. If all these categories are not satisfied, you just say category is underweight. Okay, and after that you just return BMI and category. Okay, so in the earlier function we return BMI only, and we can see here I can return more than one output. So I'm returning BMI and the category both. Okay, so it is here. Oh, this okay, then it won't be. It has this column has to only after this if or else if or for or def, not after this statement. Okay, now I have to call my, first I have to call this function body mass index using the two values I want, which is 65 kilograms and 1.64 meter. Okay, but now we want to, I put my BMI, which will take the value of the BMI returned by the function, and then my category. Okay, okay, let me print those values, both values. Okay, print my BMI, my category. Okay, okay, so it says 24 and it is normal. So we can say if it is greater than 18.5 but less than 25, it has to be a normal category. So suppose I increase my weight to 68, okay, it goes into category of overweight. Now you can see it's 25, so this condition is satisfied. We can simply increase, maybe put it 80. Oh, it's still overweight because it's 29. Okay, then I can see 22. Okay, now it has gone to over. You can see this BMI is now 30, so it has got into this category. Okay, so this is another slightly more complicated example of function, but I think you got the initial or basic idea how to write function and how to use it. So you can see that I don't need to change anything here. Once I've defined my function, I can just call it as many times as I want and just provide the new values. I don't have to go and disturb this function. And the whole calculation of BMI stays within this block, within this function. So it's easier to interpret or easier to understand this code. Okay, so now I think, okay, so I have covered the main. Okay, so this all five things we discussed till now, they're all part of core Python programming language. Like, yes. So, and then, as I told earlier, the real strength of Python lies within this, the packages. There are so many packages that that make our life easy when we're doing analysis. So we don't have to write explicit for loop, or kind of reduces the kind of computation we need to do for in our analysis. So one of them is Pandas, which is like really helpful, and much more helpful when one is doing data science. I think more than 80% time we are playing with Pandas. So in data science, the general perception is that there's machine learning, deep learning and all, but most of the time you will be dealing with these Pandas. So Pandas is mostly, you can say, is the
Sudhir, we have a question
yes,
in the chat box. It's before you go to the next topic.
sure.
Can we put input value endlessly after completing the command, or I should write it again?
You don't need to change the function. Am I getting the question right? No.
I think what it means is
Maybe he can unmute and ask directly. Is it possible?
yes.
Sure.
Yes, can you unmute yourself? Okay, so I think he's fine with that.
So you can.
Okay, he got it. So I think, Sudhir, you can switch to the next one. I mean, this is more interesting because I understand till now, more or less, these ideas are reiteration from C or C++, and just the syntax is very different, right? So there is any syntax library just
No, there's no syntax library, but actually I have my own notebook, which has the collection of all possible, I mean, at the practical level, all the syntaxes kept in one notebook, like the notebook I'm using to whatever discuss here. So you can directly look the syntaxes there. I have made a collection for myself. So I think that should be useful. I can share it later.
right.
Yes, because yes, it is. I mean, but anyway, Python is like very popular, and there are like maybe thousands of tutorials on YouTube or anywhere.
No, that's perfectly fine. So I think you can switch to the next one.
Yeah. So just to add into that, the function thing, I passed only two numbers, weight and this thing, weight and height. You can pass as many as you want, and instead of these numbers, you can pass a list, you can pass a tuple, and you can pass a function itself. So you write a function, and as the argument input, you can pass another function. So it's very kind of flexible and very powerful. Okay. So I think I've slightly clarified on that. So yes, this pandas is the Excel for Python. It is very flexible. It's like really the place to do. I mean, the software to use for data analysis. So you can understand. You can see it's called data frames, and I have put one example of data frame here. Okay. So what this is, this will look exactly like Excel sheet to you, but the good thing is that since it's the part of Python, so you can use this is in a programming language. You don't have to do like by hand or by visually all the time. So Excel like feature, but in a programming language, and that's you can put for loop, if condition, and all those features on this kind of Excel sheet, you say. Okay, so this is the data frame here, what is shown on the screen. So first, this is the data for rain. Okay, in some town, I don't know. So this is, you can see that the 12 rows. So this is the data of rainfall for 12 months. It says that, and over some historical duration, they say last 30 years. So the first column is what is the average value, what is the average of the highest rainfall in that month. So it's average high. What is the average of the lowest value? What is the highest value in this 40 or 30, 40 years, whatever, for that particular month, and what is the lowest value, and this average precipitation. So you can see all this data is kept in this Excel kind of things. So basically these columns are called features. Features means something that describe your system. So we are using rain here. So my rain, understanding of rain will be described by average high value, average of low value, record high or record low. So all those are characteristic or the feature that describes rainfall for this 12 months. Okay, and once we have this, I think let's see some features how in basically in code how to use these pandas and how helpful it can be for doing analysis. Okay, do I have the, give me a moment, I am not sure I have the file here. I need a file. Okay, weather.csv. Okay. Okay, so now I'm going to show some important features of pandas. Okay, so pandas is not a core Python thing, it's a library. So we have to first call it. Okay, so I say import pandas SPD. We can directly call pandas, but we say SPD because that shortens the name, because we have to use it a lot more time. So we will use a nickname or the short name for the libraries, for the library panda. I just call it panda here. I just do shift enter, and now I have the pandas library in my Jupyter notebook to work on. Okay, now you can see how to open this. So I say I write df, which is basically data frame, and I say call panda by pds. So I call panda, I say read csv, and this is basically my data file. Okay, so I call pandas, I tell pandas that you have to read a csv file. Csv file means comma separated values, where the values are separated by commas. I can show you the file. Okay, you can see this is the raw data file, January, February up to December, and these values, and you can see all the values are separated by comma. So this is one of the format to keep data, and this is the most popular format. I don't know why, but this is the most popular format, at least in data science, in the data science community. So yes, so this is the file, and I open the file. I provide the file name, which is weather.csv, open with panda, and all the contents of the file will be in this name, variable name, which is df, which is called data frame, because the whole thing is data frame. We can give any name also. Also, I can give 1x or like say maybe Sudhir, anything. But typically we write it df, that tells me it's data frame. So it's easy to read. Okay, df. Okay, so now my whole, once I execute this line, I have my whole data in df, and we want to see it. Okay, if I write df.head, so df is the data frame, I call head a function on that, and this will show me the top 5 rows of the data, top 5 rows. Okay, here. If I don't put any number, you can see more than 5. If I write 10, it will show me 10 rows. Okay, so we can, by using this head or thing, I can look at what data sheet I have, what data frame I have. So suppose instead of the head, I want to look the bottom 5 rows. If I don't put any number df.tail, it will show me, tail means from the below. So you can see it will show the below 5 rows of the data frame. So you can see that, okay, lowest is December, so it picks the last 5 from the below, and you can see here df dot, if I put anything, it picks the top 5 January to February. So this is one way to look at the, just look at the data file, what contents are there. We can look at the columns. Okay, and one good thing is that, very useful method is that I take my data frame and I say describe my data frame to me. I said this is my data frame, give a description of the data frame. So this will give me some statistical description of the data frame. Okay, so just it will directly count how many, the count will tell how many values I have for this particular feature, what is the mean value, what is the standard deviation, what is the minimum value, maximum value, all those things. So in just one line, we can get mean, because as say mean value and standard is very common when doing any analysis. So just one line I can get mean and standard deviation, and mean max, all those quantities very readily of all my features, which are basically average high, average low, up to average 50%. I don't need to calculate anything. I just call the method describe and it tells me all this detail. It can go further, it can go give us more and more high level information, but it's good to start with mean and standard deviation. Okay, so suppose okay, suppose I don't want, okay, so this is the whole data frame, and basically as I told you, these are called features. So sometimes when you do analysis or like machine learning, we don't want to consider all the features. I want to select the few important ones. Suppose I decide that I want to take only average high and average low. I don't want to consider, because if you consider more and more features, it's more and more computationally expensive to do it. So suppose I want to take only these two features. So I say df may be short, and okay, this is the new data frame I'm describing, and I take my data frame, I write this way, and then I write average high, okay, and then average low, okay. I compute this thing, okay. Okay, so see, if I don't want to consider all the columns, means all the features, I want to consider only two features, I can just write this thing and I have a new data frame which has only two columns. I don't need to worry about this, and then I can do analysis. So these are some, this one. Okay, we can do one more thing. Okay, so let's remove this thing for now, it's not important now. This is how to select the row. Let's remove this also. Okay, if you want to run everything in one go, you can just write kernel restart and run all. So this is, if I want to individually run a cell, I do shift plus enter. But if I want to, if I do this kernel run all, it will run all the cell, the whole code. Okay. Let's see how another feature of this. Suppose, let me write, suppose I want to add these two columns, average high, average low, into a new value. Sometimes just like you want to add all the values to columns to have a new feature. So let's write average, sorry, average of, sorry, sum of high, low. Okay, let me first try it and then describe what's happening. df average high and average low. Okay, let me first try it then here. df into, okay. So what I said that suppose I want to add these two columns and get another column which these two corresponding values added. 79 added to 59, 77 added to 57, 58 added to 42. And this kind of scenarios will occur very commonly when we are doing analysis. The two values I want to add them and reduce it to one value. So to do this, I just take data frame, the name, I select this column, average high, I select the other column, and just write plus between them and give the new name I want for the column. So see, and it will create a new column. So this column is a new column which adds the values from corresponding rows of average high and average low. These are again some functions which is quite useful when going for analysis. We can do one more thing. Let's say I want to multiply all these values by 2. Okay, so you can do one thing. I just take the column which is df. Okay, first I write to data frame which is df, and then I have to select the column name. Average precipitation is the column name, and that we have to put in this inverted commas precipitation. Okay, so let's see how it's happening. Average precipitation. If I just write, I take this data frame, I take this particular column and multiply by 2. So all the values will be multiplied by 2. This kind of data transformation we can do using this simple one or one line commands. Okay. Okay, let me see what other interesting thing we can do with it. Okay, so let me again remove these things which are not important. So we can do something else. Okay, let me just run again. Okay. Suppose I want to find what is the no, give me a moment. Okay, so suppose I want to sort this array. I can sort this, sorry, not array, data frame. I can sort this data frame by any particular column I want. So suppose that I want to sort this thing using record high column. So let's do this thing, then it will be more clear how it's happening. So first, sorry, I take my data frame and then I say sort by values. This is the Python, pandas command. And then I have to put by which column I want to sort it. Okay, I can do this thing. I can see. So this data frame, if I want to sort it by one particular column, which is record high, I just do this thing. I take the data frame, I call sort values, provide the column name. And you can see this new data frame here is sorted according to record high. So it starts from 73, 74 here. So again, these things are kind of things are very useful when doing analysis. We want to have these things ordered in ascending or descending order. So one has to simply write these simple commands and this will be kind of done. If you use explicit methods in C, C++, or if I use some Python and for loop and if condition, this will be like many lines of code, and which is basically those many lines of codes are now behind the screen. So one can directly use this in this pandas package, so that we don't have to invest a lot of time and worry about bugs. So okay, so I think this is some few features about pandas. I showed you very basic things, but it is like, I don't know, it's like maybe 100 times more powerful than I showed here, but it's like introductory level, so very hard to go to some more and more advanced levels, but we can do that if maybe in next session if we like. Okay, so also if it's good to know that once you know that, be familiar with pandas, that this is the library to do analysis, one can just like always explore by stack flow or like Google and then do it. It's very easy to use. Okay, okay, so the one, this very important package of Python is this matplotlib, which is used for visualizations. So you can look at this kind of plots like histograms or the line plot of the pie charts or other visualization. This is also very easy to make in Python using this library, which is the main visualization library uh, for Python. So let's have a little introduction to that. We won't be able to cover that in detail, but let's have a little bit, at least one or two picture to get familiar with that. Okay. That's all. I'm removing this pandas, and let's have a little introduction to visualization. Give me a moment. Okay. Okay. So as I saw that here to do this analysis, okay, let me clean again. Okay, so to this analysis, we have to import pandas again. So I import pandas as PD. There's another library we need to import, which is NumPy, which is used for most of the numerical calculation in Python. I call this numpy as np. And then for visualization, you have to use matplotlib. So I call this import matplotlib basically, and have to do this pyplot, which has some library. Matplotlib has some other extensions also. So I call this extension, and I call by this name plt. Okay. Okay, nice simple. Let me just write one more thing. You don't need to understand this, but let me just write. This is just to make it easier visualization. Okay, so as earlier, I have called a data frame. I have to use some data to do the visualization. So I call another data by using the same pandas as we saw earlier. So this my DF is data frame. I call panda, and then I use the read CSV function to read my data, which is immigration unto Canada.csv. Now the data is read in this DF. I can see what is in the data file. Okay, so basically this is data of immigration from different countries to Canada in different years. So you can see these are the countries' name from which immigration happened to Canada in years going from 1980 to 2012, I guess here. 2013, I guess. 2013, yes. So this is the data which you are going to use for visualization. Okay. If you want to understand how many rows and how many columns are there in the data frame, you can just simply call df.shape. That will give me the idea about the shape of the data frame. So this data frame has 194 rows and 39 columns. Okay. Okay. First, I will do some simple calculation with simple modifications. Perhaps you don't need to understand that. Okay, I will just do simple thing. So I just put df set underscore index country in place. I'll take a minute to explain it. Here. Let me first write and then tell what I'm doing. List map string range 1980 2014. So basically what I did here is that here, don't need to understand this part. Here is that I took all these values, all the year values from 1980 to 2013. So these are the name of the year. I put all the names in one list. You can see here. Okay. So this is basically years is basically a list which contains all the years that are in my data frame. So that using only variable years, I can get the data of all these years which are in this list. So this is just so that to easily take the data out, I don't have to put the year value again and again and again. Okay, so now let's plot the line plot. Okay, so let me just, okay, so in this Jupyter notebook, I am doing programming only, some writing code. You can write some notes also. But for that, you have to go to cell, and then instead of code, which is default, you have to select markdown. Once you write markdown, you can write notes in line plot. It's just like this one, okay? So you can do one thing, you can do code, you can write note. So this is very good, I mean, way to keep track of your code. So let's plot the immigration from one particular country, which is basically Haiti. So to do that, now look at my data frame again. Let's have a look at here. Here. So this is the data frame. I have the country name here, and I have all the years for which the immigration happened here in this different columns from 1980 to 2013. Okay, so once I want to plot for Haiti, so what I do is I take a name, I say, give me the data frame for Haiti, and then I take the call the data frame name, which is df, and say df dot, then go to a particular location, block miss location, and which location, and then say location I provide Haiti. So this goes to data frame, which is df, it goes to a location Haiti, and then so it picks the row Haiti, which is sometime below, should be somewhere here. I'm showing top 5, but it should be somewhere in the middle. So it picks the row Haiti, and then it picks, once I write the years, it will pick the columns which are in years. So it will pick the columns from 1980 to 2013, because that is what I'm writing here, okay? 1980 to 2013 in a list. So here I am getting the data for country Haiti and for the columns years, which is 1980 to 2013. Okay, so all this data is in here. You can see here. Okay, now you can see plotting here. I got the data only for Haiti and for all these years. Okay, so basically matplotlib want the data in a certain format for plotting. So we have to make a little change. Let me first make the change, and then I say df give me the transpose of it. So I take the data frame df and I call the transpose function on that. And let's see what is the df underscore underscore frame. Okay, so as simple as that. So I take the data, you can think of as a matrix, give me a transpose of that. So this will give me a transpose like this one, matrix transpose. And I am doing this because matplotlib wants me to input data in this format for plotting. It has to be support. I mean, it has to be given in certain particular format so that it understands what is x-axis, what is y-axis. Okay, now plotting is very simple. So you can see my data frame is now df Hathi transpose. Okay, so for plotting, I just simply take df Hathi transpose. This is my data frame name. I just say go call plot function on that one, plot, and then I say I want line plot. So I say kind is equal to line. Okay, see, simply one line you can plot this thing. Just take the data frame, call plot function, which type you want. It does that simply. Okay, maybe you can do some fancy thing. Suppose I want to add a title to this thing, so I call plt, which is basically, if you look at that, plt, which is basically the matplotlib. Okay, so I say that call matplotlib this thing and give me a title. So I say dot title, I write immigration from Hathi. Okay, and do this thing. See, it has an house title. You can add X label, and years, and then I want a Y label, which is number of immigrants. Okay. You can see very basically just only one line of plotting, and then other details we can provide simply. So 3-4 lines we have the good enough plot to go. You can see that once you have the data frame, it's very easier to do visualization plotting also. So this is quite useful. I mean, there are other softwares also, but this is one of the good ones also. Okay, let's do one more kind of plotting. So we have this thing. It is called line plot because it's a continuous line. Suppose I want to put a bar chart. Sometimes we need different kind of plot. So suppose I want to plot a bar chart instead of line plot. So let's see how we do this. So now for that purpose, we take the data for Iceland. So I say df underscore ice, which is Iceland, and then I take my data frame and I go to location. Now I will go to Iceland and then go to year. So this will give me data for Iceland for all these years 1980 to 2013. You can just plot here and then see. Okay. Again, we see here. So first we have to make that, sorry, just take the transpose of it. Df underscore ice. Okay. But that's not required. Mhm. Okay, so sorry. Df underscore ice. Okay, now let's see how to do this, how to get this bar chart. So I take my df ice underscore tran with transpose, and then I plot and I say I want a bar chart. So here, okay, fixed size. You can put fixed size and you can have as many like width and height you can increase. So I say width I want 10, height I want 6. Okay. Now you can see, now we have a bar chart where we have the number of immigrants from Iceland to Canada for different years. You can see this again using 2-3 lines of code, we can get useful plots for our analysis. So I want to stress is that matplotlib, the Python library, which is really kind of very useful and very easy to do this plotting and all. Okay, so there are so many other things you can do, but I think I have given kind of okay kind of introduction, and there is like thousands and thousands to play around with this. So I suppose you can play with that. I mean, you can start playing with the notebooks I will send you, and then keep learning from maybe YouTube or on the Stack Overflow and all. So I think I will stop here.
Thank you,
Thank you for.
Sudhir. I think it was quite useful. I mean,
Thank you.
these parts are bit. I think we'll go through this recording. We have a recording for everything, so I think we need to run it in our console so that we can clarify on the exact how to use the syntaxes and libraries.
Yes.
And we'll definitely get in touch with you. I think we can have a short question answer session. If anybody has a
Sure.
doubt, they can ask. I mean, I personally have a lot of doubts, but I think I'll clarify them in a personal level. But so anyone has any question, they can just drop it in the chat box. Nothing as such.
Okay, sure. So okay, anyway, I will send all these files. I mean the syntaxes I typed, I have already typed with me for reference. So I will
Right.
send the notebooks. So Python and the pandas thing, I think I covered everything there. But matplotlib, I just covered I think 2 out of 6 or 7 examples I have. So you can have look at the examples there, can play with it, and I have other Python materials on GitHub for which I will give the link. So you can just keep running there and keep learning. It's anyway I have to learn by playing with it.
Okay,
I
brilliant. Yeah. Sudhir, I have a question from Manutos.
Sure.
Yeah. How do someone save data in a file?
Okay, so this is very simple. So once you do analysis, you just I think the command is write df dot to csv. It just saves that. Okay. Okay. I'm sharing my screen now. Wait a minute. So my screen is still sharing. I'm sharing it. Okay.
Yes, please.
Okay. So let me show you. Okay. Give me a minute. Sorry. How to save data in pandas. Okay, this is how you do it. Always go to Stack Overflow. I know it's df.2csv, but let's confirm it. Okay, this is df.2 pickle, which is more of a advanced one because it saves in some, I think, binary format and all. Right. Okay, so you don't have here, but it's something called df.2_csv, and you give the file name and it will save the data frame there.
So this can be converted to different file settings, like I can choose the file format I need.
Yes, exactly. Yes, you can save the data frames in binary format also, which is much no, less storage intensive. So you can do that thing. I always use it, df.2csv. Yes, here, see. Yes. This is how you save it. Yes. So I used too many data frames, like I started df equal to pd.csv. That was to read it. So suppose I want to save the Hathy transform. So that was df_Hathy_tran. I go to that and then I put .2_csv, and then just in the bracket I put the file name. Exactly the same thing that we saw there will be saved exactly as it is. So yes, we do analysis. So of course we want to save the analyzed and the more the cleaned file in the format we want. We can save it here.
I don't see any other question. I have a very naive question. I mean, it's just
just 1 minute. Is Manotos from our batch?
Yes.
Oh,
Manotos from our batch. Yeah.
Yes. Go on.
Yeah. So I have a very naive questions. That is like in console, how do you call this? Like because I understand like you are not using Windows, right?
Yes.
So I tried to actually call this this
Yes.
file, the test file you sent, and so I'm not being able to do that. So is
Okay.
there
So yes. Let me jump in. So first thing you installed Anaconda for Python 3. Okay.
right?
So once you install this thing, I think in the Windows you have on the left below we have this something called start or control. Huh?
Yes.
Go there and then from there you launch Anaconda. Okay.
Yes, perfectly fine.
Okay, perfect. Once you launch there will be some, I think, some 7-8 tabs. One of them will be Jupyter Notebook. Okay.
Okay.
From Anaconda Navigator, it will take the full screen, and there will be so many things, Pile Lab and all. You take Jupyter Notebook. Once you click on the Jupyter Notebook, you can go to any directory you want. So you can go to the directory which you have kept your file, and just open that file. And that file will open in browser.
So it needs to open in a browser, right?
It will directly open in a browser. You can see here, I am also doing all this analysis in a browser. Yes. So this is not the earlier thing we used to write codes on a terminal and then running that. It's more interactive. So that's what it's called Jupyter Notebook. It's like notebook. You are doing analysis and then you are writing comments. So this is very useful.
So I understand. I have been trying in Jupyter Prompt apparently. I have like Anaconda Prompt.
No, don't try that. So you open Anaconda Navigator from control panel, and then open Jupyter Notebook and then go to the directory, whatever directory you want. Okay. Because I'm also using that for reference. So I was using my brother's laptop, which is Windows, doing that. So okay, if it's having difficulty, you can let me on the call and then get figured out.
Yeah, sure. I can do that at a personal level. So anyone else has any other question? Because I think like Sudhir put in a lot of time into this today. Thank you, Sudhir. I mean, like,
yes,
it's very useful.
Okay, let me put one more thing. I don't know. Okay, so other things maybe we can capture later, machine learning and data science.
Right.
Okay, but I just think that if you want to have more Python materials, you can see here. this is my GitHub page.
Mm-hmm.
And actually I have, I was telling you that all these syntaxes I have kept in one Jupyter file. So this has kind of everything there. So you can directly have the file here on my GitHub page and refer to that.
Brilliant. We'll do that. And I just have one more thing that is like, frankly, because the reason to actually name this workshop as a career outreach is because we actually want to give a flavor to the students that what would it feel like to become a data scientist. Like many of our students are from physics, mathematics,
Okay,
and
sure,
all
sure.
that.
Yes, sure, sure.
So
Perfect, perfect. Yes.
I have one more
So,
question also from another student.
okay, so should I answer this part or answer it later?
Yes, 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 please, like, go ahead.
Okay, so I mean, my context is different because I have done PhD, then 3, 4, 5 years of postdoc, and then moved. So now I have my different sets of reason. My reason would be like, to put in very simple one line, is that I didn't want to do more of abstract theory and all. So I wanted to move to something which is more of applied, but still carries the flavor of science. So, and this, as we know, that this field kind of really came up to some good level in 2015, 16 and all. So I think it came at the right time. Of course, I started learning it late. So that was my reason. So if you want to do science and then, but on a more applied level, so that thing, data science is a good one. Uh, Academically, I think now I'm fine. I feel more happy doing data science rather than my the physics thing that I enjoyed in PhD, but not so much after that. So that would be my main, I think, reason. And the things, if you want to learn to know in detail how to move to data science, I think this guy from NTU, Singapore, who did a PhD there, and he has written a very good article here. So I would suggest to read this thing, how I moved from physics to data science, and kind of things you need to know to be in data science is like, have to know a very good, have understanding of statistics, and then you need to have a knowledge of programming. So mostly right now is Python and R, but as everyone is saying, the Python is going to be, I mean, it's kind of leading the race now. Earlier it was R, but right now it's Python. So I think it's good to learn programming in Python. Machine learning is already very important, but you don't use it so often in, because I said, and also you don't use much now very complex levels, or like suppose deep learning and all. So basic machine learning, which is linear regression and logistic regression. So 95% of data science works, I mean, data scientists work with that. So yes, although it's a big name and one should know it, but I don't think it's just 5 or 10% of your work. Mostly analyzing the data, looking at the statistics, and putting whatever intuition you have. So basically, I wanted to correct the impression that machine learning, everyone has said that machine learning is data science. It's not true. It's just one part of it. Maybe it's just 10% of data science. Another thing you need to know is domain knowledge. That is something that if you want to do research in physics, I need to know about physics models. So same thing if you want to work in healthcare or you need to work in finance, then you need to have a domain knowledge, and that will come only when you start working there. It's hard to get from outside. But if you want to move into this thing, I think it's good to focus on statistics, programming, and machine learning. Technically, these things need to be learned. Yes, that's all.
Great. Yeah. Thank you, Sudhir. Yeah. So I think we're almost closing today's like time. Uh,
Are there a question there on the chat box? Or so move on.
there is one, but I think it's resolved, but you can still pick it up.
At the very beginning, you imported NIMP, but did not use it though. What is it about?
Yes, exactly. Because something like, say, okay, actually, I picked up because I didn't know which example I'm going to use. Okay, so it's called NumPy. So NumPy is, you can say, is doing mathematics for Python. So Python has a dedicated library for doing mathematics. Suppose you are doing matrix multiplication. Okay, so the one thing is that you can just run a for loop, pick one element from this array A, from matrix A, pick this element from matrix B, multiply it and give it to me. That's one thing, which is very raw. So NumPy is, you just write NumPy A dot B. So that will do the multiplication, the matrix multiplication for it. So these kind of things, like no, anything you can think of mathematics, Python does. Python has a dedicated library which is basically NumPy for it. It's called numerical Python. That's the full name of it. Numerical means play with numbers. Yes. So we have slight confusion because most of us have evolved from programming in Fortran and C. So we think in terms of language, in numbers only. But Python is not that. Python is a more general. So one particular, the numerical thing is kind of assigned to NumPy, which is numerical Python. I hope it's clear.
Sir, I have a question.
Yes, yes.
Sir, I think matplotlib calls the NumPy library internally. Is it right or wrong?
I don't think so. You can try. Okay, that's a very good question. Okay, let me also learn. I don't know. I don't think so it's required. Okay, let me remove this thing. NumPy. Let me remove pandas also. Okay. If it's okay, let me clean also so that we don't have anything hanging from our last code. Okay. Yeah, it's running. If it is calling internally, then we don't need to provide it. I think it may need it but it is doing internally. It's calling, importing by itself. So we don't need to put for that purpose. But anyway, we can simply do the matrix multiplication. Very hard for me to understand. Type here. Okay, let's take 2-3 more minutes and then insert cell below. Okay, I forgot how to define because I also don't remember everything. It's very hard to remember all the syntaxes. Import NumPy. Let's define a matrix A, which is NumPy dot array. Okay, and then 1, 2, and maybe 3, 4. I think this has to go inside. Okay. Yeah, perfect. Okay, then insert A, which is, yeah, perfect. So this is how you define a matrix in Python. So I say give me NumPy and define an array, which will define matrix with the 4 elements. First row is 1, 2, second row is 3, 4. You can simply define B, again similar NP array. Okay, sorry, I have to go inside and then maybe like 5, 6, 9, 10. Okay, now we have two matrices. Okay, now I give me C is equal to NP dot I guess A comma B. Okay, and after that C. Okay, yes, perfect. So here I define an array. For that purpose, I need NumPy. If I don't define NumPy, it won't work because I have using here NumPy. So I have to import it. I called NP and I defined a 2 by 2 matrix 1, 2, 3, 4. I define other matrix B, which is again 2 by 2 with the element 5, 6, 9, 10. And I say NP dot dot. So this basically does the matrix multiplication. So I say A multiply by B and give me the multiplied matrix C, which means C. You can verify it. Yes. So that's good. Thanks for this question. We got to see a little bit of NumPy also.
Okay, thank you very much.
Welcome, welcome.
Okay, nice. So is there any more questions? Because we are almost closing this session. So we'd definitely like to have more from you, Sudhir. I mean, like whenever you have some time to get into
Yeah,
more advanced ones.
certainly I have time, but my brother is leaving, so I need another laptop to for referencing. So that
That's
is
perfectly okay.
so we'll discuss it. Certainly, as I talked in the first few slides, this is the first part. We didn't move into data science, so and that itself is, I think, more than 1 hour of discussion topic. So about that, I take the raw data and go to the modeling. So they take the data, do some analysis, do cleaning, some transformation, and how to put in a machine learning model. So we can do that. I have the materials ready for it. Or we can have a theoretical session on machine learning, like just describing the theory and the, the machinery behind it, rather than go into implementation. We can discuss it on a private call.
Right, brilliant. Yeah, Sudhir. So thank you so much, Sudhir. I mean, like this has been a very enriching and like for me personally, it's very useful because I personally want to use these tools into my research, and definitely it would be very intriguing for the students, I understand.
Sure.
So we'll interact more on this one. I'm so sorry, like there was some technical problem with my computer, I think, but I'd like to take this opportunity to thank you particularly for your time. I mean, you're very busy, I understand that. And like the organizing committee, our patron, our Professor Falguni Mukhopadhyay, who is our honorable principal, sir, and Chair Dr. Gautam Mukherjee, sir, who is the HOD in physics in BC College. And the secretaries for this program is Dr. Sudipta Roy and Dr. Somin Chakraborty, and joint secretaries Ajay Kumar Sharma and Apurva Paramani. We are actually picking up from earlier program on the International Career Outreach, which happened in June. So we were trying to get more and more exposure, like so that the students and like us also, we get more and more exposure to the like highest level of the technologies that like state of art that is coming up. So frankly, like Sudhir and I go way back 10 years. We did masters together, and Sudhir eventually moved into his PhD in IMSc and postdocs from USA and then NTU in Singapore. And then he did several of this data science courses. So Sudhir, thank you. And I look forward to having you again in some of our programs. And you do understand, like some of our students may actually reach out to you to
Perfect. I would like
some
that.
consultation. Yeah.
Yes, sure. So I would suggest that keep playing with it because I learned Python 3 times and I forgot. Fourth time I learned and I started using it. So that's the only way. If I stop now and I don't use for 6 months, I'll forget it. So the only way to learn it is keep using it, and now feel free to reach out to me or Amit and for anything. Get started, whether it's Python or data science or machine learning or whatever you like to ask. I'll be happy to answer.
Brilliant. Thank you so much, Sudhir.
Welcome.
So I think you also take a break because I think you're constantly talking for last two hours.
Yes.
It'd be like we'll talk soon again, and thank you everyone for being such a nice audience. We'll speak soon again. Okay, Sudhir, you do take care. I'll speak to you soon again.
Sure. Thank you everyone.
Thank you. Take care. Bye-bye.